Welcome everybody. In this video, we're going to be exploring a variation of extracting data from the HTML that we have collected. Specifically, we'll be taking a look at CSS selectors and how they differ to the beautiful soup implementation that we've been using now. Additionally, we'll be taking a look at the imports and how they work. Maybe if you haven't had your head around these statements over here, after this video, you should understand it. Additionally, we'll be taking a look at a strategy pattern. And speaking of a strategy, we have this block of code here, which is a way to collect, a single way, a single implementation. There can be many different implementations, and each individual ones of those implementations will be considered a strategy where if we have a process of collection, and in the middle of that process sits logic that looks like this, we want to be able to take that logic, lift it up and swap it in with a different strategy, and this is called a strategy pattern. We'll take the logic that we have here and let's get some key components out of it. I'll draw a box around it. We have it over here. We then have a response.texts, which is passed from outside of the box from this response. We then have opponents over here that we're consuming that is inside the box. This is something that comes from inside the box, and then we're using it. What I have drawn here is essentially a function. A function is your black box that you put stuff into, and then you get stuff out of it. The stuff you put in are called function parameters. The stuff you get out is the return value to which the function evaluates to. Let's get rid of this box, take this code and shift it to another file. We'll create a new file. I'll call it BS for beautiful soup. And then the thing that we're extracting, which will be opponents. So opponents.py. Here we have a file, and before we do anything serious in this file, let's just print 1. We'll then define a strategy, just a function, notice with its own scope, and we'll print 2. We can then print 3. This is again if you don't understand scopes or bodies of things. Coming back to main.py, we're not importing anything just yet. We'll run our application, python main.py, and we should see standard stuff being outputted. I will actually just remove all the stuff that we're printing out here to get rid of the noise. From the start of the application up to the 200, we don't see 1 or 3 or 2 being printed. That's because we haven't actually imported the file. Over here, let's go ahead and import BS opponents. We will rerun the application and we should see 1 and 3 being printed. Notice 2 is not being printed because at this point we just say that a strategy function exists, and when we execute the function, the body of that function will execute. Furthermore, over here we can place print before, duplicate this, place it at the bottom and say after, rerun, and we will see the order being respected. We're reading the file line by line, top down. As soon as we see import statement, we jump into this file and read it top to bottom. Furthermore, we can reuse the same syntax here. So from BS opponents, we want to import our strategy. We'll then take the strategy and execute it over here. If I don't execute this, we're never going to see the 2. However, I am executing it, so we're going to see a 2 being printed after the after. Okay. Same thing happens with the other imports. These imports reside in our venv, so you can see BS4 is over here, and then the requests package is over here. When Python sees the statements, it will go into one of the scripts here and load up the logic that you need. Let's collapse this because we don't want to look at that anymore. We'll delete the debug prints that we have placed here. We will then go to main.py. I'll hide the terminal and select the strategy block that we have outlined before. Control X to cut it. Go to BS opponents, paste it over here. The error over here basically refers to this function not having an indentation here because function has a body, and at the moment this function doesn't have a body because no indentation. So we want to just indent it to make sure we specify that this belongs to this strategy function. And these lines of code are going to be executed when we execute this strategy. Let's give this function a better name. We're going to be getting opponents by the end of it, so let's get opponents. We don't have beautiful soup. This is a dependency that we will require. Let's cut the import from here, again using Ctrl X. Control V to paste it at the top here. And now we have beautiful soup. As I've drawn the box previously, I said that we'll have function parameters and a return value. The HTML that we're passing from the response will be a function parameter that will be passed from outside into here. We then want to return this opponents array after filling it up. However, if we don't return anything, we'll replace the strategy with get opponents. We will not call strategy here anymore. We will get opponents over here and pass response.text. By the end of it, we are going to be getting our opponents and print them out. Okay, and rerun our application. And the thing that we get from get opponents is none. That's because we don't return anything. The way you return a value, or you make a function evaluate to a value, is you use the return keyword followed by some kind of value or a variable which contains a value. Okay, let's run the script, and now we'll see one being printed. If we then further go ahead and return this opponents variable from this function, this is going to evaluate to an array with our opponents. That will look something like this. Okay, coming back here where I actually call the function, rerun it, and we should end up at the same result. Perfect. Now let's take a look at another strategy. We'll take BS opponents, copy the file, we'll rename the file, remove the copy, and put select after BS. That will basically stand for CSS selectors. And now, what is a CSS selector, and perhaps even why are we looking at it? Beautiful Soup allows you to use CSS selectors, not just the Python object navigation method where we're saying here's a Python variable, navigate to a child element, so on and so forth. Hopefully you still have the page of Khabib open. I mean, I don't even turn my computer on without having this page open. Okay, first thing that starts up. Let's open up somewhere over here, so right click inspect, and here we have the element tree. And again, as I said in the first episode, the browser is your ally. Before you get to your Python code, all the strategies you can test and try things using your browser. In the element tree over here, you can press Ctrl F and notice that you can find elements by string. If we try to look for Poirier or something like that, we may find an element that's here or just a piece of text that's there. However, there's also an option to use selector or XPath. Notice that there is no option there to use Beautiful Soup. Beautiful Soup is Python specific. If you're ever going to traverse to other programming languages like JavaScript, C#, Clojure, anything else, it's not going to have Beautiful Soup. There has to be some kind of more generic or some kind of other language that can specify how to extract data from a web page. Selector and XPath. XPath is something that we're going to cover later. Selector or CSS selectors is a way to do this. CSS selectors are a way that the people who build web pages can specify that this block of text is bold, and then this block over here has to be green. This is a link. This is how a link looks like. They basically style their web page using CSS selectors. You can use CSS selectors to then traverse the HTML tree and find the elements that you want. Let's say that we want this table, and what I'm going to be showing you here, you may think, how do I know how to write this? It's a well-defined syntax. Somebody has gone ahead and written it. All you need to do now is practice it. I already know it. The way I know it is I wanted to select some specific members. So in Google, I typed in my problem. How do I select element X using CSS selectors in this some kind of condition? And then I browse for the results. Maybe there is some kind of answer there, or I will take a look at a CSS selector documentation and try to pick out what I think is relevant. But anyway, let's take a look at this table right here. We will right click on it and we will add an attribute. And I wanted to add ID, my ID. So this was from practicing this episode before. So let's say, yeah, we don't have this my ID here. I want to add an attribute, ID equals my ID, and a way to select using CSS selectors a table with an ID of my ID. First you specify the name of the element, which will be table, and then you use a hashtag to say I'm about to select by an ID, and then you specify the value of the ID, which is going to be my ID. And you can see we zoom in on this table over here. Because I've manually appended this ID, it might not actually be there. So if I double click on this or remove the search and remove my ID, I will press Ctrl F again to try to find it. And instead of my ID, I'm going to use wiki table. I'll use .wiki table. This is going to select me some table that is actually in front of the table that I want. I can see that the main difference between these two tables is that first one has more than one class. However, it does contain the wiki table class, but mine has only a single class. And I can zoom in on my table by basically saying that the class should only contain a wiki table. If I take a look at this style, so again, I'll have to close the search, double click on the style and just select all of it. I will then press Ctrl F again, and instead of searching by class, I can search by the style attribute, so it has this specific value. And this is where you have to put your judgment in. What looks like a more reliable selector? Something that says wiki table or something that says font size 85%? How many things can have a font size of 85? You don't know. Many things. How many things can have a wiki table? Well, it sounds like at least all of the table elements, which is what you're looking for. You have to apply your judgment around which selectors you want to use. Don't just use the selectors that fetch you your element straight away, because one problem with web scraping is you're depending on things that aren't yours. What is going to happen very often is you will get rug pulled. You will depend on some solution, they will change the website, and your stuff breaks. So you have to go ahead and fix your web scrapers. Additionally, a way that you can find the CSS selector that you're looking for, if we right click on the table, we go to copy, and here you can see we can copy the selector, we can copy XPath. Again, XPath we will take a look at later. So let's copy the selector, see what it gives us. It will go to MW content text. Let's shift end to select all of this end stuff, Ctrl X to cut it, and we will see that this isn't really selecting anything, although I think it refers to this div where the ID is set to this. Okay, so you don't necessarily need to specify the element, you can just go ahead and work with the individual attributes. You can see that it's using a selector of nth child. That means we're doing a little bit of positional stuff. Again, doesn't look like the most reliable thing, so let's try to replace it with a wiki table. I'll copy wiki table over here. I will remove this, I'll press a dot, and again, we're at the same result here, so I will revert back to specifying that my table should only have a class that contains one wiki table class, and that is it. From there on, I can look for TR elements that are here and iterate over them. If I want to make sure that I navigate to them through the T-body element, I would type out something like this, but again, you would look for CSS selectors. You would find a website that looks something like CSS selector reference, W3 school, and here you can have this stuff. Let's say we'll be taking a look at nth child. Click on try yourself. And what you're doing here is essentially practicing CSS selectors and how you would scrape things. If we're looking for li elements, there they are. We want to go ahead and grab the third li element, which is going to be this third list item. Here you can see it selects every third element amongst any group of siblings. So let's go ahead and get rid of that. We don't want that. We will place a 3 over here and we'll run. Now we're selecting the third list item. And if we select the fourth one, we're selecting the fourth one. Okay. This is a way to practice CSS selectors. However, you're not marking things. You're not searching for things that you're going to scrape. At this point, you're actually building up the HTML page that would have been displayed to a user. So before this page is displayed, some kind of developer goes through this process where they are styling their web page. But anyway, that's a way that you can explore CSS selectors. Beautiful soup. If we Ctrl F for CSS selectors, there will be a whole section in here that describes how you can use CSS selectors. Let's re-implement our strategy using CSS selectors. We are going to come back to our application. We're still loading up beautiful soup. You can see that by the documentation still using soup, and we're selecting the title. Let's copy this code over here. Instead of finding all tables, we want to select a table that has a class of wiki table. If you want to use double quotes in a string, use single quotes to wrap them, and then let's just get rid of this space. We'll take this statement that we've just written up and replace the soup find all. This is going to give us a bunch of tables. If you're ever lost at any point, pause the video, print, see what you're working with. And that's just what we're going to do. We're going to say print tables. Going over to main.py, we'll duplicate the import. We'll comment out the previous one and we'll use the select import. And just like that, we've switched over to a different strategy. Let's rerun our application and we have a collection of tables here. We will be selecting the very first one because now we know that we're zooming in on a specific table, and this is still going to contain all of our matches, although now we will be selecting all the TR elements from it. The rest of the logic can look the same, although in our TRs, instead of finding all, select the nth element. This is where, again, I will need to remind myself of the CSS selectors because I can't exactly remember how it referred to the nth element. Nth child selects every p element that is the second child of its parent. We will use nth child, so we want atd nth child second. However, CSS selectors start indexing from 3. Remember that we had the first row which contained headers, so the individual TR or the opponent node, maybe none at this point. So if not opponent node, if it is none, let's skip it. Otherwise, we will remove this bit. And before we actually start looking at the string, let's print out our opponent node. We can grab the name, place it over here, and then a comma, and the second parameter that we print will be the opponent node. This bit right here, we can comment this out. We're not going to be appending anything to opponents, so at the end we'll just return an empty array, but that doesn't matter so much for now. We want to see the individual opponent nodes that we extract. Let's run our application, and this looks pretty good to me. Some of them do contain links, some of them don't. And as expected, the very first opponent node is empty, so we just skip it. A big note on here is that we are looking at individual elements, so we want to zoom in on the text the same way that we do here. Here we do it through a string. How do we do it with CSS selectors? Do we still use a string? Let's take a look what the CSS selectors say about it. Looks like there is a bunch of examples that just say how to go about traversing the trees. I'm gonna expect that we get the same type of element where we can just say dot string and get the actual contents. Let's uncomment this, giving us back our opponent name variable, and again trying to append it to the opponent's array. Our application might throw an exception if we try to strip from an element, although I'd expect a TD that has an anchor inside of it to return an empty or a non-string. So let's see what's gonna happen. We'll remove this print here. We will remove the print of the table, which gets printed above there. We don't really care about it. Come back to the bottom of the terminal, and I just wanted to put a couple of spaces here, and rerun the application. And we get an exception. Again, the first bit here is the stack trace, and then there is the error. It's pretty much descriptive. We have an attribute error, result set object has no attribute string. If we take a look at the things that were printed out again, notice the square braces around this. A set is a type of collection that doesn't contain duplicates, whereas a simple collection could contain duplicates. So that's the only difference with a set, but nevertheless, the point here is that set is still a collection. That means we should be able to extract the first value out of it. Instead of opponent node, these are going to be nodes. And then out of the nodes, we want to extract the very first one. And if we don't want to change all the code that is going down here, let's create our new opponent node and extract it from opponent nodes and not it, rather the very first element. We will put a couple of spaces here, retry the application. And just like I mentioned before, if we have an anchor child element, that means the string is going to be none, and a none type doesn't have a strip function. Only if we have some kind of strings here, this is going to work. If this variable is going to be none, strip is not going to work. Let's take this if statement and bring back the selector for the anchor. Having the opponent node, we will select the anchor and we'll get the string. Remember that select selects many things, so we just want to say 0, that we just want the first element. Furthermore, we can expect this to only contain a single element, and because it's a collection, we can just extract a single child out of it. Let's see if this will work. Looks like that was a blunder, so we'll come back and actually properly try to select a child. We'll rerun this, and we end up at the same solution. One thing that we can see here, this first element selection is a little bit uncomfortable. Let's see if Beautiful Soup allows us to do anything about this. We'll go all the way back to the top where we can see the CSS selector section, and there are no child sections here, so unfortunately we will need to scroll through this a little bit. Everything says select, select, select. Finally, there we have it. So select one. Instead of selecting a collection or looking for all the childs and then appending them to the results array, same as we're doing with opponents, we just want to specify select one. Okay, well, let's grab this method name, come back to the code. Instead of select, we'll say select one. This now again becomes opponent node, and as long as that's not none, we're good. We can delete this line of code, and then we can do the same thing here. Select one, which is going to be just the anchor, and then we'll grab the string. We will rerun this and end up at the same result. Just collecting the names is a little bit boring, so let's set ourselves up for also collecting the links if they're present. We already know how to get the containing anchor of the specific TD, and instead of appending individual names, let's actually create an opponent dictionary. So opponent, this is going to be a new dictionary, so just an empty object for now. And what we're going to do with the name is, once we find it, by the end of our extraction, and let me hide the terminal, we're going to slap the name into the dictionary under the name key. We can do the stripping right over here, and then we save the opponent in the opponents array. We'll bring the terminal back up, rerun the application. Now what we're saving to the file are individual opponent objects, and we have their names. We can now put additional attributes like their Wikipedia URLs. The way that we reach these, we go back into BS Selector, here where we have the anchor. Let's grab this A, put it here, sometimes specifying opponent anchor, blah, blah, blah. You're writing too much, okay? As you get a little bit more experienced, having very verbose names actually harms you. So in this case, we're just going to extract the anchor. We're still getting the opponent name. And then we're going to have the opponent link. At the beginning, this is going to be none. However, if we do enter this if statement, we can take the opponent link and instantiate it to the href over here. We can quickly verify that indeed we're getting it by printing the opponent link over here, rerunning. We'll see a bunch of nones, and that is perhaps because we're using Beautiful Soup incorrectly. Let's jump to the top and let's see how we can get an attribute. Looks like it's a dictionary notation where we have to specify square braces and then provide the key for the attribute. So square braces and then the key, which is going to be a string value of href. Rerun the application. And here we can see a bunch of links. The opponent link, we can duplicate this line of code, specify link, and then set the opponent link over here. Remove the strip, and notice that we just have the slashes. What about if we go back to Wikipedia, grab the actual domain of Wikipedia, and before we assign the opponent link, we want to also append the domain. Now, if we append it to a none, we're going to have a problem, so we want to do it for this opponent link that we have here. Let's put a string, then we're going to specify that it's an interpolated string. At the beginning, we'll pop the domain, and then inside of it, in curly braces, we're sort of saying, at this position, put whatever value is going to be here, which are going to be these values. Let's save, rerun the application. If we take a look at Khabib opponents, again, format the file using Alt-Shift-F, we can see some opponents that do have links, and if we open them up, and you can see we have one additional slash, although the link still works. Let's give that one last cleanup, remove this slash, recollect, and now we have proper clean data. The opponent and his link. Now we can go ahead and create another component that is going to look for all the opponents and collect those additional opponents. And then we can create an even bigger loop where we're saying start at one fighter and keep going until we have collected all unique fighters that have participated in the UFC, and try to order them by some kind of metrics. Same as we have collected the names and the links, we can collect their wins, their losses, who has lost to Khabib the most times, who has had the most fights in the UFC, this kind of information. Why it's useful? It's useful for practice. But for now, this will be it for this video. Thank you very much for watching. As always, don't forget to leave a like, subscribe. If you have any questions or want to say thank you, leave it in the comment section. If you want the source code, come support me on my Patreon. Big thank you to all of my patrons that are already supporting me. Your help is very much appreciated. Thank you for watching the video and have a good day.